Assalamualaikum warahmatullahi wabarakatuh, and hello to Tuan T.S. Azno and Puan Liu. We are from Group 2. Today we're gonna present about our Cad Mini Project, that is combination wrench. So my name is Idi Yamin bin Baiti Yamin. My number registration number is 01FTV 25F1012.
My name is Ahmad Syarif bin Muhammad Nordin. Matric number 01FTV1B FTV 25F1042.
My name is Muhammad Jamshid bin Juzamri. My registration number is 01FTV 251015.
My name is Hasbi Fahmi bin Amiruddin. Matric number is 01FTV 25F1008.
For number 1, my role in this project is I am responsible for providing information that is used for our writer report and presentation. This includes gathering accurate details about the object and explaining key part of the project to ensure clarity and understanding. My role is technical analysis. The technical analysis is responsible for ensuring the overall technical accuracy and quality of the drawing produced throughout the project.
Okay, my name is Idin Yamin. My role in Group 2 is to draw the combination wrench using the Autodesk Inventor and prepare the project report.
In the team, my role is editing. The role of consistency. I make sure content is logically organized and maintains a consistent voice and tone throughout.
For the introduction of our project, we selected a combination wrench as our project. A combination wrench is an essential tool in the mechanical field because it can stand both an open and head and a ring and head. Since this tool requires precision during operation, the technical drawing must also meet the same level of precision. In this project, we also apply the concept of reverse engineering. We began by taking accurate measurement of the wrench in millimeters. These measurements are important because even a small error can affect the accuracy of a technical drawing. All measurements were then transferred into a CAD software where we rate the object according to engineering drawing standard. Our final output include a third angle orthographic projection, which present the front, top, and a right view accurately, and for isometric projection, which provide a three-dimensional projection of the wrench. But the drawing includes proper annotation, dimension, and a layer organization, ensuring the drawing are clear, readable, and complete. That's all for me. Objective Number 1, to identify a mechanical part which is the combination wrench and capture its original image in asymmetric view. Number 2, to apply the concept of reverse engineering to measure and determine all object dimension in millimeter. Number 3, to use CAD software to redraw the wrench, displaying both isometric projection and third angle orthographic projection. Number 4, to organize the drawing using at least 3 layers and to prepare a drawing with complete and accurate annotation and dimension. Number 5, to produce the final plot drawing in PDF format A3 size that is well organized and professional.
Okay, firstly, this is the original picture of the Cad Mini Project, that is a combination wrench. Combination wrench is a common hand tool used in mechanical and maintenance work because it has two functional ends, that is an open end and a ring end head. So, in this project, I began by capturing the picture of the combination wrench at the mechanical workshop, automotive. After that, I began after I captured the picture, this helped me to shape of the wrench to the visible, including the length, the dimension of the handle, and the shape of the ring end and the open end jaw. This picture is important because it becomes the reference for all measurements and drawing created later. For accuracy, I applied the reverse engineering method. I measured every part of wrench manually in millimeters, including the width, thickness, radius, and angles. These measurements were then used to recreate the drawing accurately using Inventor software. Okay, now this is the orthographic isometric drawing. This drawing used the third angle projection method, which is the standard in engineering drawings. The orthographic projection consists of three main views. First of all, front view shows the true shape of the wrench. Second, top view displays the width, length, and the curvature of the body. And lastly, the side view shows the thickness of the wrench. These 2D views represent the object in true measurable way. Each line type in the drawing has a function. First of all, object lines shows all visible edges. Second, hidden lines that we can see in the drawing. It's colored by green, show features that cannot be seen directly from the view. Then hidden lines, center lines, cyan. My group used a cyan for the center line, that is highlight the symmetry and circular centers. Lastly, dimension lines and ladder line. We use red for these dimension lines, and this dimension line is to show the accurate measurements of the combination wrench. This orthographic projection is essential because it communicates the real size and the shape of the wrench clearly and precisely. Okay, now this is the isometric projection view. The third picture is the isometric projection drawing. This drawing presents the wrench in a 3D-like view. It combines height, width, and length, and depth in one illusion. Unlike the orthographic projection, the isometric view helps the viewer understand what the object actually looks like in real life. In this isometric drawing, the proportions and shapes from the original object are maintained using the measured data. The 3D presentations make it easier to visualize the overall geometry, including the thickness, rounded features, and the tapering of the wrench handle. Now, I will explain about our discussion section, which covers line types, projection types, material, and layers used in the drawing. First of all, type of lines. The drawing used several important engineering line types, such as object lines to outline the visible shape of the wrench, hidden lines to show invisible edges, center lines to indicate circular features, dimension lines to show measurements, lastly, ladder lines to point to specific details like radius or diameter. These line types help communicate the correct information clearly and professionally. Second, types of projection. There we have two types of projections used in this project. First of all is orthographic projection drawing. Orthographic projection drawing represents the range in 2D views. Front, top, and side view. Shows accurate measurements and true geometry. Second, isometric projection. Provides a 3D presentations, helps visualize the real shape or the overall appearance of the original object, which is combination range. Thirdly, type of material. In this project, we use steel polish as the material for the range, for the combination range. It's very strong, suitable, durable for mechanical tests. Other than that, we also put some layers in this drawing. So I use different layers to organize the drawing, such as hidden layer. Hidden layer, we use the green color for hidden lines. Dimension layer, we use red for measurements and annotation. And center line, that is for symmetry and circular axis, we use cyan color. So I believe that if we using the layers, we can ensure the drawing is neat, structured, and easy to read. That's all from me.
In conclusion, the engineering drawing of the wench successfully demonstrates the use of proper line type projection methods, layer, and material selection. The combination of orthography and isometric projection provides a clear and accurate representation of the object in both 2D and 3D views. The organized layer structure improves clarity and makes the drawing easier to interpret, while the correct application of object lines, hidden lines, central lines, dimension lines, and leader lines ensure accurate communication of the wench, her geometry, and features. The use of polished steel and the material reflects appropriate strength and durability for the intent function of the tool. Overall, the drawing meets the essential technical requirements and effectively conveys the design and structure of the wench.